In this video, I'll show you how to do a simple shape optimization using the Mesh Morpher optimizer in Fluent and design points in Workbench. You can use the Mesh Morpher optimizer in Workbench to solve shape optimization problems and improve design characteristics of your system. For example, you can improve flow uniformity in a duct system or minimize drag in a turbulent flow. When using the Mesh Morpher, you need to create geometry, generate mesh, and specify a matrix of control points only once, and the Mesh Morpher will automatically apply geometry and mesh changes in the solver. Let me show you how to optimize the geometry of a Coriolis flow meter for reduced pressure drop through the system. I've already obtained results for the flow simulation through the tri-shaped tube using standalone Fluent. Only half of the geometry is considered because the tube is symmetrical. I want to investigate how the geometry changes in this portion of the tube will influence my target criteria for minimal pressure drop through the flow meter in order to select the optimal design for my system. I've started a new session of Workbench. The first thing I want to do is save my project. I'll create a new directory for my project and give it a meaningful name. I'll use the same name for the project and its directory. When I click Save, Workbench creates a folder tree where various files associated with the project will be saved. Now I need to import the case and data files from my previous simulation into my system. I'll open my project folder. The quickest way to do it is to view files associated with the project. In the File view, I'll right-click the location of the project file and select Open Containing Folder. Now I'm going to copy the case and data files to the User Files directory located in my project directory. I want to save all my files that are not directly generated by Workbench in this directory. This way I can keep all my files together with the project files. I'll also copy the file path for later use. The case and data files appear in the file list in Workbench. The next step is to bring the Fluent-based system into the project schematic. I'll change its name to Fluent-Original and add a note. Do not change. I'll right-click the system header and select Properties. The note appears in the Property view. Now I'd like to import and associate the case file with my setup cell. I'll right-click the setup cell, hover over Import Fluent Case, and select Browse. I'll paste the path that I copied into the address bar, open the containing folder, select the case file, and click Open. The setup cell is up to date. I'll import the data file associated with my case file in a similar manner, and save the project. Now, both the setup and solution cells are up to date. The next step is to generate an interpellation file. I'm going to use this file later to initialize the solution variables to speed up my simulation. I'll click the solution cell to display its properties and select Data Interpellation. The state of the solution cell becomes Update Required, so I'll right-click and update it. Fluent has generated the interpellation file. And once again, save. I want to keep my original case and data files, so I'll create a duplicate system and work with the duplicate instead of the original system. If anything goes wrong, I can always delete the duplicate system and use the original that remains untouched. I'll rename my duplicate system to Fluent-MMO, then click the green triangle and edit the note to read Initialized with the interpellation file. With the duplicate, I'm going to edit the setup cell and open Fluent. I'll enable parallel processing with 4 processes and click OK. In Part 2, I'll cover how to set up the Mesh Morpher optimizer for my case.